This video is on arc length. Our learning target is learning target 1. I can solve for an arc length. Let's review two important measurements of circles. The first measurement is the circumference of the circle. This is the distance all the way around a circle, as if you were walking around in a circle around the edge of, say, a circular fence. We do this by using the formula pi times diameter. Remember, a diameter is made by doubling the radius. Let's do this quick little example. I want to calculate the circumference of the circle with a radius of 6. Since my radius is 6, I'm going to double it to make a diameter. So my circumference will be pi times not 6, but 12. And my answer for doing pi times 12 is approximately 37.7 centimeters. The area of a circle is the space inside the circle, basically how much we could fill up the interior of a circle with. It's found by using the formula pi times radius squared. So let's try this example with a circle of radius 9. Our area would be created by doing pi times 9 squared. It comes out to approximately 254.5 centimeters squared. I can find these different measurements of circles given different beginning information, such as if I started with a radius of 2, I could double it to get 4. I could times that diameter by pi to get circumference, and I could do pi times the radius squared to get the area. If I started with my diameter, I could cut my diameter in half to get my radius. I could times the diameter by pi to get my circumference, and I can times the radius squared by pi to get my area. If I start with circumference, that means I'm given diameter. I can cut my diameter in half to get radius, and then I could square that radius to get my area. In order to find what's called arc length, we have a formula we use. Arc length is basically as if you were standing on the edge of a circle and you are walking along it, and you want to know how far did you walk. This is what would be called an arc length. To do this, we do need to know what portion of the circle we have actually walked. So we need to know two things. We need to know how far it is around the entire circle. So this is why there is the circumference formula plugged into the bottom of this arc length formula. The L is going to stand for our arc length. This symbol right here is the mathematical symbol for angle. And the 360 is always underneath it. So basically what we're saying is, what part of the entire circle circumference is the same as this angle out of all of the angles? So the arc length is a part, the circumference is a whole. The angle is a part, 360 is a whole. In general, both sides of this formula is setting up the fraction part of something over the whole of that something. Let's use that formula on this example. We have a circle with JL6. So I'm going to label that on my circle. JL is 6. We're going to find the arc length from K to L. So I start to set up my formula. My circumference is found by doing diameter times pi. And that is our total circumference of the circle. Our total degrees of the circle is 360. Our arc length, which is our L, is going to be from K to L, and our angle will go on top of 360. So let's plug in the pieces. Pi times 12, because I had to double the 6, which is my radius, to get my diameter. And we're going to find arc length, so that's the L that we're going to solve for. My angle is 80, and it's over 360, always over 360. All I have to do to solve this problem is multiply both sides by what's underneath the L. 80 divided by 360 times pi, then times 12 comes out to approximately 8.4. And it is okay to always round our answers to the tenths place. Let's try this example here. This is a good example because the angle that they gave us is not the angle that will work for the arc that we're trying to solve for. The arc they asked for is ST. The angle inside of there is not given, but they do give us this 255. Since the circle is only split up into two different arcs, we can take the 255 and subtract it from 360 first to get the angle that we need to use in our formula, an angle of 105 degrees. Now it's time to substitute these values into our formula. Pi times our diameter, which is not 10, it's double that, it's 20. 105 is the angle of the arc that we want to solve for, and that is over 360. Again, times both sides by what is underneath the arc length. 105 divided by 360, then times pi times 20 comes out to approximately 8.3. Let's do a quick example that doesn't have a picture of a circle given to us. So Shanna is about to perform a relay handoff on a circular track. She has a radius of 18 meters and her track partner Katie is standing 99 degrees from her. How many meters does Shanna need to run to pass the baton to Katie? Start by drawing a circle and labeling the information you do know, such as the radius. The radius is 18. And I'm going to roughly draw a 99-degree angle so that I know where Katie is and where Shannon is. So how far does Shanna have to run to Katie? Well, that would be the arc length using 99 degrees and 18. So let's start by plugging those things in. Arc length will be over pi times d. Our d in this case is 36. That's double the 18. And our angle is 99 out of 360. Multiply both sides by pi times 36. Multiplying by pi times 36 makes the pi and 36 underneath the L go away, leaving the L alone, which means it's solved for. 99 divided by 360 times pi times 36 gives me approximately 31.1 meters away. This example has a bike tire with a diameter of 18 inches and it's divided by wire spokes into 9 equal sections. What's the approximate arc length between each of the wires? Since there's no information about an angle given, I better create that angle measurement. So the angle measurement we're trying to figure out is this angle right here. Since each of these pieces is equal and the circle is divided into 9 pieces, all I need to do is take 360 and divide it by 9. I end up with 40. So each of these angles is 40 degrees. We are given the diameter, which is 18, so there's no need to double this number. Now let's start to substitute this into our formula. Arc length will be equal to pi times 18, 40 degrees over 360. Let's get rid of the pi and the 18 underneath the L by multiplying by pi and 18, but do it to both sides of the problem. And my arc length will be equal to whatever 40 divided by 360 times by pi and 18. Approximately 6.3 inches. Key here in this problem is knowing what to do with this 9 to create the 40. In our last example, we want to know how long the radius is. We are given the arc length. So that means this 10 is my L in my formula. It is not the radius, it is not the diameter. So that means it belongs on top of my fraction, and pi times d will stay on the bottom. Again, one more time. We are given the arc length from S to T, but the angle they gave us is on the other side. So we need to take 360 and minus 255 to get the right angle, 105. Now I can plug in 105 into my formula and put it over 360. I don't change my steps at all. I still multiply by pi and d. This removes the pi and the d from the bottom of the fraction. 10 is now equal to 105 over 360 times pi times d. The next step would be to get rid of the 105 and the 360. So we can get rid of the 360 easily by doing the opposite of divide by 360, and that is times by 360. And lastly, because the d is being multiplied by both the pi and the 105, the opposite of that would be the divide by the 105 and the pi. But don't forget to do this to both sides. So my diameter will be whatever I get from 3600 divided by pi and 105. I end up with approximately 10.9. Divide this by 2 to get our radius. 5.5 rounded off. Okay, that covers it for arc length. Make sure you hit the submit button so I have record of you watching the video.